So I do usually record my first geometry lesson, so that means I'm recording during your class.
Hi.
Hi, Alex. You're over there.
Where?
In the front. So today we're going to start chapter 6, and chapter 6 has to do with polygons. Okay, so today we're going to find interior angle sums, exterior angle sums, stuff like that. So first off, I do want to just go over names of different polygons given the amount of sides they have. So if I have a three-sided polygon, what's the name of that?
Square.
Three sides.
Square.
Garrett, three sides.
Triangle.
It's a triangle. All right, four sides, you'd probably think, oh, it's a square. It's not a rectangle either. It's a quadrilateral. Okay. Squares and rectangles are specific quadrilaterals. Five sides is a pentagon. Six sides is a hexagon. Seven is a heptagon. Eight is an octagon. What'd you catch up? Sorry, it's going kind of fast.
You have an extra pencil?
Are you serious?
I'm dead serious. Oh,
Oh, did you get one?
I got one.
If you have 9 sides, it's a nonagon. Do you know what 10 sides is? No. It's a decagon. Like, you know, decade, dec is 10. 12 is dodecagon. And then any other side, say I wanted to say there's 27 sides or something like that, you would just say it's an n-gon. So however many sides it has. So I would say it's a 27-gon or a 32-gon, something like that. Okay? You're not going to need to memorize all of these. You will need to know the quadrilateral is 4 sides. Okay? Because we're going to be dealing a lot with quadrilaterals and different types of them. So you will need to know how many sides that one is. I think you guys know what an octagon is by now. Triangle, and a decagon probably, for sure. So next thing I want to go over is the diagonals within these polygons. So a diagonal is a segment that connects the non-consecutive vertices of a polygon. Okay, so you can't connect the consecutive vertices, again consecutive meaning next to, because that will just connect along one of the sides of your polygon. So in our examples here below, we do want to draw all the diagonals of each polygon. So if I start at this vertice, my non-consecutive vertice would be right across here to draw in that diagonal. If I were to try and draw in one here to this vertice, that's a consecutive vertice, so it wouldn't count as a diagonal. I do have one more. Okay, if I go from this vertice here, I can draw in a diagonal across. Okay, I want you guys to do number 2. Draw in those diagonals. right, so when you draw in all of those diagonals, yes, it is an upside down star. Okay, so if I went from this vertice first, you should have 2 diagonals to those non-consecutive vertices there, 2 here, and 2 here. And same thing, 2 to all of those. Questions on those? Not so bad yet? All right, so in each of these polygons, instead of drawing in all of the diagonals, we're just going to draw in the diagonals from point A. So in this first one, point A is right here. So I can't, again, draw to that first vertice there, but I can draw in one to this vertice and to this vertice. But then again, I can't draw to that one because it is a consecutive vertice, and it would be along one of those sides. Okay, and number 4, A is supposed to be that point right there. So drawing in this diagonal, can't go to the consecutive, have to go to that non-consecutive side. So there's only one in number 4. Now I wanted you to do this just to see what the next theorem is kind of talking about. So when you draw all of the diagonals from one vertex of an n-gon, so any sized polygon, it separates the polygon into n minus 2 triangles. Okay, where n is your number of sides. Okay, so if I look back at number 3, this polygon here has 5 sides. Okay, when I drew in that diagonals from one of these vertices here, it split it into 3 triangles. Okay, so if I took 5 minus 2, I would get 3 triangles. Same thing in number 4. This one has 4 sides. If I take 4 minus 2, I get 2, and it split it into 2 triangles. Okay, that's true for any polygon. And it's going to help us figure out the interior angle sum within that polygon. So the sum of the measures of the interior angles of the polygon can be found by adding the measures of the interior angles of those n minus 2 triangles. How many degrees is in one triangle? All the vertices. 180. Okay, so I can add up this 180, that 180, and this 180 to get the interior angle sum. So this n minus 2 is going to be a big part of that equation. So if you look at your polygon interior angle sum theorem, it gives you the formula for the angle sum. It is n minus 2, because that's how many triangles you split up that polygon into. And then you'd multiply it by 180. Because you need that many triangles, and each triangle is 180 degrees. Does that kind of make sense? A little bit? So if I go over an example here at the bottom, I have a convex polygon that has 13 sides. We want to find the sum of the measures of the interior angles. Okay, make sure you are picking out those keywords because sometimes it'll say one interior angle, not just the sum. So in this case, we're finding the sum, so we are using this theorem and this formula. Okay, so I have n minus 2 times 180, where n, again, is your number of sides. Well, I'm given the number of sides is 13. So I can plug in 13 for n. Okay, so I'm going to take 13 minus 2. That's 11. And multiply it by 180. Okay, that's 1,980 degrees. Okay, so first you needed to know how many triangles there were. That's the n minus 2 part. And multiply by 180. Any questions? Okay. Then example 2 on the back, we want to solve for the value of x in this problem. So in order to do that, first I need to find the interior angle sum. Okay, so my first step here is to find the interior angle sum, because if I were to add up all of these angles, it's not a triangle, so I can't set it equal to 180. Okay, I need to set it equal to its interior angle sum. So I need to know how many sides there are. So I have 1, 2, 3, 4, 5 sides. Okay, so I'm going to plug in 5 for n in the formula we just did. So I have 5 minus 2 times 180. So we have 3 times 180. Which is 540 degrees. So now that I know that my interior angle sum of this polygon, this 5-sided polygon here, is 540, I can add up all of my vertices, or all the equations for each of those vertices, and set it equal to that sum. So I'll take angle A here is 4x plus 10, add on angle E, angle D, angle C, and angle B. Now when I add all of those together, it has to equal my interior angle sum that I found. Not 360, not 180. In this case, it is 540. Okay, if it was a triangle, it'd be 180. It's not a triangle. Okay, from here, I just need to combine like terms. Okay, so I have 26x. Okay, all my whole numbers here together is 20. And that's still equal to 540. Okay, at this point I'll subtract 20 from both sides of my equation. So I have 26x is equal to 520. Divide by 26. X is equal to 20. Okay, so you do have problems like this on your assignment. So first, again, you need to find the interior angle sum, and then you can add up everything and set it equal to that interior angle sum. Any questions on example 2? Okay, so a regular polygon is a polygon with all sides congruent and all angles congruent. Okay, so that means all of your sides, say their measure was 10, they all have to be 10. Okay, all the angles then would all have to be the same as well. So since we have a regular polygon, that's fine. we can find one interior angle, since we know they all have to be congruent to each other. That is given by this formula right here. So I still have this n minus 2 times 180. Again, that's your interior angle sum. But then I can divide it by how many sides I have, because that's how many angles you have, to get just one of those interior angles instead of all of them added together. Okay, so we can use that formula to find our numbers of sides. So that's what we're going to do in example 3 here. So the measure of an interior angle of a regular polygon is 120. So again, you do need to pick out certain information in these types of problems. So you have the measure of one interior angle already. Okay, and we want to find the number of sides. Keeping in mind your number of sides is n. So we want to solve for n. Now, there are two different ways that you can do this. So I'm going to split this up here. Okay, and we're going to do our first way on the left there, and our second on the right. Okay, so our first way is using that formula to find one interior angle. So what I can do is take my formula, n minus 2 times 180, divided by n. Okay, that's one interior angle. Since I'm given one interior angle is 120, I can set it equal to 120. From this point, I just want to solve for n. Okay, so in order to do that, I need that first n there on the bottom out of this denominator. So I'm going to multiply both sides by n so that they cancel on the left there. So I have n minus 2 times 180 equals 120n. Next, I'm going to distribute this 180 into my two values inside my parenthesis there. So when I do that, I have 180n minus 360 still equal to 120n. Now this way I can combine my like terms. So I'm going to subtract 180n. So I have negative 360 is equal to negative 60n. Again, I'm just solving for n here. So I'll divide both sides by negative 60. To get n is equal to 6. Okay, meaning you have 6 sides if one interior angle of a regular polygon is 120 degrees. If I have 6 sides, what type of polygon is that? It's a hexagon. Okay, so that's the first way. I'm going to go through the next section, little section there, before I show you the second way. Okay, so there is a simple relationship among the exterior angles of a convex polygon. By simple, I mean really simple. Okay, so I have the polygon exterior angle sum theorem. It states the sum of the exterior angle measures of a convex polygon, one angle at each vertex, is 360 degrees. There is no formula to find the sum of your exterior angles. For any sized polygon, it is always 360 degrees. It doesn't go above that, even if it says it has 900 sides. Okay? Your sum of your exterior angles is always 360 degrees. So, in example 4, when I say find the sum of the measures of the exterior angles, one at each vertex of a convex 27-gon. What would you tell me that is? By the sum of the exterior angles. 360. No work involved. It's just 360. Okay, this is why you need to pick out the pieces of your example of your problem. Okay, so if it said sum of the interior angles, that would be different. You'd have to use your formula from the front. But since it says exterior angles, it's always 360. Now in example 5, this one's a little bit different. So we want to find the measure of each exterior angle. Okay, so since it says each exterior angle, that means you just need one of them, not the sum. Okay, so this one's not 360. But I can use that sum in order to find one of them. So in this polygon, it is a hexagon. Okay, meaning it has 6 sides. Okay, meaning it has 6 exterior angles. So you'd have one here, 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 and here. Okay, there are 6 of them. Since it is a regular hexagon, that means they're all going to be congruent to each other, since all your angles are congruent. So I can take the sum of all 6 of those, which is 360, and I can divide it by 6, since that's how many I have, to get my one exterior angle of 60 degrees. Okay, so again, this is your exterior sum. This number right here is your number of sides slash angles. And then it gives you that one exterior of 60 degrees. Okay, questions on example 5? Okay, remember I have a second way up in example 3. We're going to go through that one now, that we know that the sum of your exterior angles is 360. So to do this, since I'm given one interior angle, first what I'm going to do is find one exterior. So if you look back down at this picture here on the bottom, your interior angle, if I look at angle B here, and your exterior angle form a straight line. Okay, your exterior angle isn't that whole angle there. It has to form a straight line with your interior angle. So since they form that straight line, both of them together have to add to 180. Okay, so I can take 180, subtract 120. Okay, so again, this is your exterior and interior together. I'm subtracting my one interior that I had. When I do that, I get my exterior angle. Okay, so if I know my exterior angle measure of a regular polygon, and I know the sum of all of my exterior angles have to be 360, I can take my exterior angle sum and I can divide it by my exterior angle. To get how many sides I have. Okay, so again, exterior and interior together form a straight line, they're 180. So if you're ever given one exterior and it says find one interior angle, subtract it from 180 to get that one interior and vice versa. Okay, if you're trying to find your number of sides, again, just subtract from 180 to get your exterior, then take your sum, which is always 360, divide by that one exterior angle to get your number of sides, which is also your number of exterior angles. Okay, questions on that second way there? I find that way a little bit easier, but if you like the other one using the equation, you can do that. All right, so